Problem 2, we have 3x squared plus 12x minus 24. We can use factor trees here, or you can list out the factors. So I'll just still use factor trees. 3 is 1 and 3. And then x squared is x and x. Now we have 12x. Well, 12, we can do 6 times 2. 2 is prime, but 6 is not. So what about 6? 6 is 3 times 2, and that is prime. Well, x, of course, is just x. Now 24. What can I multiply to get 24? I can multiply 2 and 12. 2 is prime, so what about 12? 12 I can multiply 6 and 2. 2 is prime. What about 6? 6 I can multiply 3 and 2. So make sure you go all the way to the prime factors, and that one does not have any x's. So now let's talk about our GCF. For the GCF, I see that they all have a 3 in common. I see these have a 6 in common, but the 3 over here does not have a 6 as a factor, so we can't use that. 3 is actually the only number they all have. Now for this one we have 2 x's, here we have 1 x, here we have no x's. So they have no x's in common. Our GCF is just 3. One way we can look at this and know about the x's is take the one with the lowest amount of x's. This one has no x's, so I can't take any x's out of all of them. So my GCF is 3, so now we're going to take our original problem and divide it all by 3. Now when we write our answer, we put the GCF on the outside because remember that is what we originally distributed and we are unmultiplying here. So when I divide this by 3, the 3's cancel and I'm left with x squared. 12 divided by 3 gives me 4x, and then 24 divided by 3 gives me 8. So this is my factored form. I want you to try the next one. So here's our next problem. We've got 4x to the 5th minus 6x cubed plus 10x squared. Pause the video and try it, and then play the video and check your answer. All right, now that you've tried it, 4 goes to 2 and 2. And then, of course, x to the 5th is x times x times x times x times x. Well, 6, that goes to 2 and 3. And then x cubed is x times x times x. Then 10, that goes to 5 and 2. And x squared is x times x. So now let's find the GCF. What do they all have in common? I see that they all have a 2, and we have 5 x's, 3 x's, and 2 x's. This one has the least amount of x's, so I can take 2 x's out of each. So what's my GCF? They all had a 2 in common. They all have 2 x's in common, so my GCF is 2x squared. Now we're going to write out our original problem and divide every term by 2x squared. All right, we'll start writing our answer. 2x squared is the GCF, so that goes out in front of the parentheses. 4 divided by 2 gives me 2. X to the 5th over x squared. X's are top heavy here, and we subtract the exponents. 5 minus 3, I just told you the answer. 5 minus 2 gives me 3. Now we have a minus. 6 divided by 2 is 3. X to the 3rd, top heavy, 3 minus 2 is 1, so just x. 10 divided by 2 gives me 5. X squared over x squared cancels. So there we go. Number 4. We have negative 14x minus 21y. What is different about this one than the other ones? Well, one thing that's different is that our leading coefficient is negative. So let's write a little note here. When the leading coefficient is negative, we have to factor out a negative every single time. There's my leading coefficient, it is negative. So I know when I come down here for my answer, I know my GCF has got to be negative. I have to factor out the negative from both of them. So now let's talk about the factors. Well, 14, that can go to 2 and 7. And then, of course, we just have x. 21, that can go to 7 and 3. And then we have y. So our GCF here, what do they both have in common? They both have a 7. And they have x and y. Are those in common? No, those are different variables. So the GCF on this one is just 7, but notice what we have to take out of it, that negative. So our GCF is going to be a negative 7. So now let's take our original problem, divide everything by negative 7. So our GCF is negative 7. I'll put it there. Now, negative 14 divided by negative 7 gives me 2x. And negative 21 divided by negative 7 gives me positive 3y. So again, you have to factor out the negative. Number 5. We have negative 8x squared minus 12x plus 4. I want you to pause the video and try it. All right, let's do this one together now. Well, we notice that that's a negative, so we know that our GCF has to be negative. Well, what about the 8? The 8 goes to 4 and 2, and then the x squared goes to x times x. Now, you'll notice that I actually didn't break down the 4. If you want to, you can go ahead and break down the 4. But if you're able to visualize it, look at 8, 12, and 4, and think in your head, what do you think they all have in common? I'm thinking it's going to be a 4, so that's why I didn't break it down further. Now the 12 can go to 4 and 3, and then of course x is just x, and the 4 can go to 1 and 4. So what do they all have in common? They all have a 4. This has 2 x's, 1 x, and no x's, so that means our GCF will not have an x. It'll just be negative 4. You have to factor out that negative. So now we'll take our original problem and divide every single thing by negative 4. All right, the GCF is negative 4. Negative 8 divided by negative 4 gives me 2, and then I've got x squared. Negative 12 divided by negative 4 gives me positive 3, and I have x. And 4 divided by negative 4 gives me that negative 1. If you're ever working on one of these problems and you look in the parentheses and see that they still have something in common, like an x or a 2, then you'll need to factor out another GCF and just multiply them out here. All right, next problem. Number 6, we have negative 12x squared y cubed plus 5xy squared. Notice that this one has x's and y's, but we still do the same thing. That negative, we have to put it in our GCF. And what about 12? Well, 12 goes down to 4 and 3. And 5 goes to 1 and 5. 4, of course, can go to 2 and 2. Do these have anything in common? Do 12 and 5 have anything in common? No. And if you're able to just see that without the factor trees, then you don't have to write the factor trees. So there's no number except for just 1 in common. And then x squared, of course, is x times x. Y cubed, y times y times y. We have 1x here and 2 y's. So now what do we have in common? We have 1x in common, 2 y's in common. So what goes in our GCF? Of course, we took that negative coefficient from the front. Now we have 1x and 2 y's. So that means our GCF is negative xy squared. So let's divide our original problem by that and see what we're left with. Don't forget to take out that negative. Negative xy squared. So I know that goes first in my answer because it's my GCF. Now we can start canceling. Well, a negative over a negative is a positive. We leave the 12. X squared over x, that's top heavy. 2 minus 1 leaves me with x to the first. Y cubed over y squared. Top heavy, we subtract and are left with y. Now over here, 5 divided by a negative is a negative 5. X's cancel. Y squared over y squared cancels. So we're done. All right, number 7. We have 2/3 y to the 4th plus 1/3 y cubed minus 4/3 y squared. This one looks a little different because we just have fractions. So we're still going to ask ourselves, what can we take out of every single fraction? What do they all have in common? Well, they all have in common a 1/3. So we can take out 1/3 from each of them. That's part of our GCF. What about the y's? I see y to the 4th, 3rd, and 2nd. When they all have y's, we can take the least amount of y's, y to the 2nd, and put that in our GCF. So we know our GCF is 1/3 y squared. Well, 2/3 divided by 1/3, if we need to, we can put that in our calculator, or of course, we know that 2/3 divided by 1/3 is the same as multiplying by the reciprocal. So the 3's cancel and we're left with 2. Y to the 4th over y squared, subtract the exponents, so y squared. The 1/3's cancel, and then y cubed over y squared leaves us with y. Then on this one, 4 cubed, 4 over 3 divided by 1/3, we're going to be left with a -4, and the y squareds cancel. Number 8, I'm going to write it and then I want you to try it. 4x squared y squared plus 12x squared y minus 8xy squared minus 4xy. Now that you tried it on your own, let's look at it. I want us to do this one in our head. If you did the factor tree, totally fine. But look at 4, 12, 8, and 4. What do they all have in common? A 4. So we know that in our GCF, we can take a 4 out of every single one. Well, let's look at the x's. X squared, x, and x. What's the least amount of x's? 1. So we know we can take 1x out of everything. Y squared, y squared, y. They all have a y in common. The least exponent is 1, so we know we can take out a y. So we take our GCF, 4xy, we put it out front. Now we start dividing. The 4's cancel. X squared divided by x leaves me with x. Y squared divided by y leaves me with y. 12 divided by 4 is 3. X squared over x is x, y's cancel. -8 over 4 is -2, x's cancel, y squared over y is y. Then on this one we have a negative, 4's cancel, x's cancel, y's cancel. So we're left with -1. All right, I already wrote in numbers 9 and 10. These look a little different because what do you notice? We have x times x plus 1 minus 2 times x plus 1. So actually our GCF here, what do they both have in common? That x plus 1. So that's our GCF. That means we're going to divide both of them by x plus 1. We're going to bring that down as our GCF. GCF is x plus 1. Well, what happens when I divide these? They actually cancel the entire parentheses, and I'm just left with x. What about here? 2 times x plus 1 divided by x plus 1, they cancel, and I'm left with -2. So this is our factored form. When we see the parentheses are in common, we'll take the parentheses, and then we'll just group together the leftovers. Last problem, very similar. I want you to pause the video and try it. All right, let's check it. What do they have in common here? Those parentheses again. So the GCF is y minus z. So let's divide both sides, or both terms, by y minus z. Well, that's my GCF, so I bring it down to my answer. What happens when I divide these? The parentheses cancel, and I'm left with x. What about these? Again, cancel. I'm left with plus w. So that is the factored form. If you have any questions about any of these, feel free to ask in class the next time I see you.